Welcome back to Alaska. Last fall, I visited Fairbanks with some friends and stayed for 17 days straight. In that time, we were able to see northern lights for 14 of those nights. But it wasn't as easy as you might think to get a 10 out of 10 display. In this video, which is a follow-up to my Aurora forecasting series, as well as my first Alaska and autumn video, I'm going to show you how to Aurora Nowcast, a method of setting expectations and properly positioning yourself to be right under the auroral oval for the most legendary of northern lights phenomenon, coronas. On the previous 3 nights, detailed in that first Alaska video, we had difficulty with cloudy weather right over the Fairbanks area and to the immediate north and east of town. This condition means driving to areas where there are cloud shadows off mountains and clear skies. And while this did give us a great view of the aurora, they weren't particularly active enough to be right overhead. KP numbers barely cracked past 1. This meant watching aurora from a distance as it dances over the northern and eastern horizon. The auroral oval at rest, or weakest state, is normally positioned a couple hundred miles north and east of Fairbanks. But an auroral oval at rest, or just KP0 or low KP1, isn't all that normal. Probably the most common state of the oval, and the KP index is about 2, where the oval extends right down to Fairbanks. For comparison, Yellowknife in Canada is directly under the oval during a KP0, while Senja and Tromsø in Norway are right under the oval during a KP1. So sometimes in Fairbanks, you'll need to move around a bit for the best view, either because of weather or because of aurora strength. But Fairbanks has an unfair advantage over those other locations. There's lots of roads to choose from, and in every direction. So being directly under the oval is simply a function of knowing where to drive on a given night's aurora strength and where that matches best with clearest weather. You could of course take a shortcut and hire a local guide, but after watching this video, I'm confident you'll be able to do this on your own, or at least admire what your guide needs to work out to get you a fantastic view. In my Aurora forecast series, I made it a point to help make it possible to understand what kinds of parameters are needed to see the northern lights in the lower 48 of the US or northern countries in Europe, and how the auroral oval is displaced in the direction of the center of North America. In Alaska, this creates a bit of a quirk. Northern lights aren't really north so much, but rather somewhat east. Especially before midnight, east and north are the directions to go out of Fairbanks to be under the oval on weaker days. So under the most optimal weather conditions, you'll want to use the Stees Highway to get into position for a weak display. A KP0 or KP1 will place the auroral oval comfortably over Circle or Central Alaska. But be warned, you've got a long gravel road starting near Eagle Summit, a 3,500 elevation pass up above the timberline. During a KP1 or 2 event, Eagle Summit itself is a great spot for viewing aurora overhead. But it's going to be cold and windy, and again, be mindful of the dirt roads. But also during a KP2 event, you might not have to drive that far. Along the way are many different pull-offs of varying quality and good views above and to the northeast. Closer to Fairbanks, just north of Fox, Alaska, is a great place to be during a stronger event. However, I'm not in love with what is the so-called Cleary Summit Aurora viewing area. There's traffic, trees, and even power lines obstructing your view, but it makes a pretty good last-ditch option if areas further to the northeast are cloudy. Along the Stees, make a quick stop at the Poker Flat Research Range for a nice rocket selfie. This range is specifically for aurora and magnetic field research. Once into KP3 territory, really all of interior Alaska starts to get into the action. Fairbanks, North Pole, Delta Junction, even Denali might experience overhead aurora on these stronger days. I say stronger in air quotes here because that is still considered well below storm conditions and is actually quite common. Perhaps as common as 3 hours each day, even during solar minimum years. Your next option is the Elliott Highway. Along this highway are, again, dozens of places to pull off the highway, often intended as rest areas for truckers. But bear in mind, this is a busy stretch all night long for semi-traffic. You might get blinded by extra bright semi-truck lights every 10 minutes or so. Fine for viewing aurora, but a little annoying when making time lapses. Because you'll be traveling nearly parallel to the Auroral Oval, almost halfway to Coldfoot, Alaska, on the dirt Dalton Highway, use this road if that's the card the clouds have dealt you. It's a long, lonely stretch of road with no services. Use this road with caution and careful planning, and avoid it altogether during bad weather. Most of this stretch of the Dalton and Elliott highways will work out the best in KP2 or KP3 conditions. You'll also find some of Alaska's most stunning fall color up the Elliott and Dalton, and it takes a long time to get way up here, and these are rather marginal roads. Traveling at night along these roads is a bit scary, with lots of blind twists and turns, and startling encounters with moose pedestrians. Also paralleling the Auroral Oval but to the south is the Richardson Highway down to Delta Junction, Alaska. This is the safest route. There are services, there is a bit of traffic all night long, and the road is paved and smoothed. In each of the cases I've mentioned before, when driving at night, be very careful about wildlife crossing the road. In the course of 2 weeks, we had to dodge moose, deer, bobcat, lynx, and even porcupines. But along the Richardson Highway are a couple different lake opportunities for awesome ink blot test style reflections over calm water. For the most adventurous among you, check out the Denali Highway just south of the Alaska Range. Bring all your camping gear and get ready to be blown away with expansive views to the north and east. Wide open skies, glaciers, and mountain views. Stay for several nights to bet against the weather and the variability of the aurora. There are lots of places to camp along the highway, which stretches through mostly public land. Arrive early and pick your destination. Ideally here, you'll want KP3 and KP4 events, which aren't terribly uncommon either, especially in autumn. Unfortunately, cellular data service is almost non-existent, so you'll be flying blind. Fall can bring tricky weather, so make absolutely sure you are both prepared with a good weather forecast and for that forecast to be wrong. Bring extra provisions and perhaps invest in a satellite-based weather and communication tool. It's raw out here. Every sort of wildlife Alaska has to offer could be here, even the aggressive kind, and you're going to be a very long way from official help. Here's a little montage of our day trip up the Denali Highway in autumn, if you aren't convinced. But remember from my Aurora forecast series that KP is just a crude look back at the last 3 hours of geomagnetic activity. What we need to look at are the prospects in the immediate future. The normal rules apply. CMEs and coronal holes produce a more active aurora and can give days, or even in rare cases, even weeks of advance notice. But also remember that satellite data that I mentioned before from ACE and Discover. These data sets can tell us how things might evolve in the immediate future, like the next 45 minutes up to an hour. This is Aurora Nowcasting. Unfortunately, cell coverage is pretty limited on most of these aforementioned roads. The Richardson Highway does have actually pretty good cell phone coverage on all networks, while the Stees Highway beyond the Aurora viewing parking lot and the Elliott a few miles north of Fairbanks have almost no coverage at all. Generally speaking, AT&T service just happens to work a little better than Verizon in Alaska. So some service for some could mean no service at all for others. So I suggest figuring out the weather, then staging around one of the service locations I've suggested first before making a final decision and driving to your target. Obviously, if the weather is clear anywhere and you can make it to Eagle Summit, for example, forecasting the weather is less important. The aurora will be there regardless. It's just a matter of whether you are expecting to observe a weaker display and go further north or east, or a stronger display and want to hang back further south or west. To know what to expect ahead of time, what we need to watch for is a negative BZ in the interplanetary magnetic field. If solar wind conditions are fairly calm in the wind and density department, and no major changes are expected from any coronal holes or CMEs, then ultimately we just need to be watching that BZ number. Other factors do come into play, of course, but this one parameter is the most bimodal and consistent discriminator this far north. If BZ has been pointed north for hours at a time, expect northern lights to be weak, faint, and well north and east of Fairbanks. However, if BZ is pointed south, things will be more interesting. But just moments or even 20-minute increments of negative BZ aren't enough to kick off a big display. What we want to see is a southward pointed BZ for at least 45 minutes or more at a time, or far better, hours at a time. This is really easy to get in the fall when we visited, or in the spring, as negative BZ is basically the normal state of things, regardless of what the sun is up to. What's happening when the BZ is negative for a long time? We are building up hemispheric power. This is an accumulation of solar radiation being funneled through Earth's magnetic field and onto the fringes of the upper atmosphere, where atomic oxygen and atomic nitrogen can get excited and glow green, red, white, purple, and more. Use the ovation model to see the predicted hemispheric power in an upcoming time frame, usually 45 minutes to an hour in the future. In Fairbanks and the other far northern cities I mentioned, hemispheric power over 20 is not only great, it's common. Typically, hemispheric power in the 30 to 50 range in the hours on either side of midnight will mean aurora sneak much further south and west of Fairbanks. BZ values are recorded many thousands of miles ahead of Earth, and while solar wind travels at enormous speeds, there's still a 30, 45, even 90 minutes of difference in travel time from when the data is recorded to when solar wind, and indeed negative BZ, begins to interact with Earth. So be patient. If you see live drops to negative BZ and the aurora aren't active yet, wait first for the condition to arrive at Earth, and then also wait for it to begin building up hemispheric power. It takes time, but this is a good thing. If you are staying in the town of Fairbanks that night and things don't look all that active, but suddenly you get a prolonged drop in BZ, great. You've just bought yourself an hour of drive time for those amazing overhead corona shots. These same rules apply in Yellowknife, Iceland, or northern Norway. Even if the display you've got right now isn't S tier, you've got an hour of warning in most cases before you know a major display is about to take place. Again, a quirk of being in Alaska is that the aurora are more east than north, especially before midnight. After midnight, the oval begins to shift due north. So keep this in mind if you're making time lapses, or are using multiple cameras and have them in place pointing the right way before the display gets active. If you are well north of the Arctic Circle in Alaska, or somewhere between Alaska and the Hudson Bay in Canada, sometimes the aurora can even be south of you, or just all over the sky. Alright, let's talk moonlight. The absolute best time to watch northern lights is during a new moon, but don't let moonlight scare you away from watching. Moonlit, snowy landscapes with aurora can be amazing, but if you want pure northern lights and maximum enjoyment, plan your aurora trip around a new moon, when skies will be darkest. However, here's a cool little tip with moon phases during the fall. The waning crescent moon is up all night during the fall and will interfere even close to the new moon. But the opposite is true of a waxing crescent, or in other words, the week immediately following a new moon. In this case, and this might be hard to wrap your head around, the moon never rises during the night. The quickest way to explain this is that the first quarter moon follows the path the sun would 3 months later, during the darkest months of the year when the sun only rises above the horizon for about 2 or 3 hours. And of course, not at all north of the Arctic Circle. So like the winter sun, the moon either never rises or only rises for a couple of hours and mostly after sunrise anyway. So to make a short story long, new moon and the week after are the best times in autumn to visit in the far north for northern lights in the darkest skies. Fairbanks and Yellowknife have a huge advantage over Norway in autumn. The lingering sun and twilight in Norway lasts well into the autumn, while fully dark skies can be found in Fairbanks and Yellowknife as early as late August, when the weather is still pretty wonderful. Aurora coronas are the ultimate goal. Northern lights dancing and shifting above you in real time, and so bright you can navigate your surroundings with ease. And on top of that, plenty bright enough to capture real-time video on today's best devices. A big part of seeing this is chance. You can put yourself in the right place for your forecast and nowcast, but sometimes the aurora don't do the crazy stuff you were hoping for. One sort of element I've noticed is that in the hours immediately closest to midnight, the aurora might indeed be the furthest south of the night, but also kind of devolve into something my buddies and I call aurora mud. While still really cool to watch and sometimes full of crazy phenomenon like rapid purple pulses, the aurora are just more chill and a little darker than the coronas we want to see. This isn't quite as bright or dynamic, but we notice that when this happens around midnight, coronas were visible before it happened, and again later on to the night, well past midnight. So you might end up with some nights being a corona mud corona sandwich. Perhaps the best part for aurora chasing is that no single display is ever the same. Sure, you will see some of the best stuff on Twitter and Instagram, but in between those viral shots of aurora are tons and tons of hours of northern lights doing weird, subtle, and crazy fast things that you just can't capture in a photograph, but rather just need to see for yourself. And hopefully that gets you excited to go try this on your own. Heck, if you just stay up late for a few nights, hanging out somewhere nice in the middle of Alaska, you'll see them just by chance. If you haven't watched my aurora forecasting series, go get started on it now. I'll take you from the very basics all the way up to case studies, and even how to photograph them and make time lapses. So give these a watch. And I add to this series and do little sidebars all the time. So subscribe for more like this. And maybe in between, I can get you interested in some other cool earth science or astronomy topics along the way. Thanks for watching, and until the next video, I'll see you out there.